Okay, so last thing. This one's a little bit of a tricky one. Let me just bring up a little bit of a marital aid here. That's not what you call it. That's not what that means. All right. So on a previous episode of Pantrio, someone here brought up a point that I myself had also thought about, but then sort of just forgot about, decided not to address. After we kill the timer, does that mean the function will await forever and we have memory leak? And I believe that this is correct. So we should probably reject the promise when it is canceled. Yes. So, I mean, when I did my research for this stuff, looked up, how it would be best to convert the timeout stuff into a promise that we can await on. I noticed that some implementations were canceling it, but I started off by just not doing that because it was simpler not to do it, to get my working thing working. And when I did that, it worked so good that I was like, forget about it. I didn't think about it after that. But if you think about it, yeah, it does make sense that, let me see if I can explain it. Because it can be a little complicated, especially if you're not super familiar with how, JavaScript works on the browser. But first we need to go to where it lives. So let me just close all these files because there's too many files. So I mean, sleep.ts, this is our promise stuff, our async promise stuff here. And if we kill, we clear the timeout. So the resolution is promise. When the promise is resolved, that is called by set timeouts. That's called sometime in the future. When we await on this promise, when we await on the sleep, we are waiting for this function to be called. If we kill the timeout, this function is never called. So the original event, when you clicked on something or whatever, the original event that is waiting just keeps waiting forever. So if you do that every time you click and then you kill it, you're going to have these events that basically stack up and they're all waiting. And they're probably like one of them, maybe it's, I don't know. I mean, I have no idea actually how much one of these event instances, how much it costs in memory. We could probably do an experiment to measure it, but I don't want to. But let's just say it's 1 kilobyte. So let's say every time you're typing in an input, it's canceling the event, right? Until the very last one when it actually, does the API call. So, I mean, however many characters you type in an input times how many times you type in an input for every page load is how much extra memory you're going to have. So if it's like, let's say there's 200 of those for any given page. And that's probably, I mean, since this is a single page application, you're not reloading the application very often. So that's definitely doable. 200 of those uncanceled. If each one is a kilobyte, then that's 200 kilobytes of basically memory leak or whatever, which isn't huge considering how much memory Chrome uses just, by default. But it's also just not a very, it's not a very good thing to do as a programmer, right? Memory leaks, it's never okay to say, it's fine. You should fix them. That's my philosophy. It's super hot take, I know, but freeing up memory, probably a thing you want to do. So, how do we make sure that when we clear this thing, it actually, the promise actually resolves? Well, there's two things. We can either call the resolve function when we kill as well. So resolve will be called either by set timeout or when we kill. And then things will resolve as usual. And the process will continue. But that's not what we want, right? Because if we're awaiting on sleep, that's because we want to delay and then some process will happen after that. But if we kill, we don't want the next process to happen. We want to stop. Just don't do it. So the other thing you do is there is a second parameter that we get in here from promise. And that is, is it cancel or is it reject? It is reject. So when we kill, we actually want to call reject. Now this has one annoying side effect. And that side effect, I believe, is that if we await on something and it is rejected, that will throw an exception. So we have to catch the exception. That's the only downside. But it's still good. I like it. I like it a lot. So that's what we're going to do. So for this to work, first of all, kill switch has to have a handle on the reject function for the promise so that they can reject it. So we kill switch, we bind. We're going to bind the timeout ID, and we're going to bind the reject function, which is some kind of function. Can I just do function? Or callback or something? I don't know how that works on TypeScript. We'll have to figure this part out. We'll figure it out. If we can't figure it out, we'll just say it's any, and that's good enough, right? So now we take in two things. We take in resolve. We also take in reject. So now we're to the promise, we're passing a function. The function takes two parameters, the resolve and the reject. Set timeout should call the resolve, but we want to give reject to you. You will store the reject. Private reject is function, or can be null because the kill switch might not be targeting something. And there we go. This dot timeout ID is equal to that. This dot reject is equal to reject. Okay. So this should give our kill switch handle on the rejection. Then, if we clear, we should also clear this. And then if we kill, we should clear the timeout. And then we should reject. I can see in my head, I feel like there's a race condition, but there probably isn't because JavaScript doesn't have multiple threading. At least not on a browser. So this dot reject. Now I cannot call it without any parameters. I might be able to, but it's not liking me here. Cannot invoke me. That makes sense. How? I mean, I could just do a test in here. This dot. That's one way of solving that problem. I don't know if it's the best way, but it is one way. I mean, if the thing is here, if this is not null, this necessarily has not to be null based on, you know, the design of our object and our encapsulation here. In which case, I don't have to do the extra test. I could just do this, maybe, or maybe it's this. Maybe it's this. Yeah, it's that. I'm just saying, no, don't worry about the null. I got it covered, bro. Now we could also pass things to the reject, and that's probably a good idea because if this causes an exception to happen, we would like to be able to differentiate an exception due to the sleep being killed as opposed to an exception because something crapped the bed. If something crapped the bed, we probably want to do something about it, at least report an error. But if it's kill switch, then that is normal. We don't want to do anything bad about it. So let's go. Let's see how this works, first of all. If it works, first of all. And if it works, how it works. All right, let's reload this bad boy. So far, so good. Let's type. Here's where things are going to crap the bed. Type. Okay, undefined. So this makes sense. Maybe. Try catch, runtime. So what I'm thinking is that when you reject, and then you await on the promise that was rejected, it's going to throw an exception. It's going to throw an exception, and the exception object that is thrown is whatever you pass to reject. since we don't pass anything, nothing, not even a null, the thing that is thrown is an undefined exception. And since we're not catching any of our exceptions from that, that just escapes outside. So what are we going to do here? Well, I'm sure that there are some best practices for creating, exception objects. Maybe things that you should put in them that will work with the browser. I don't really know. I don't really know about that. So what is a good way of creating an exception? JavaScript instance of class. I believe in JavaScript we can do something like this if you got one of the newer flavors, one of the newer ECMAs. New rabbit, yeah, class rabbit, new rabbit. Is this an instance rabbit? So that's what I want to do. So, I mean, I could spend a lot of time researching and finding out the best, most idiomatic, most best practices way of doing this, but I don't feel like it. Not right now. We can always make it better in the future, There's always room for refactoring. For right now, I want to do I want to export? I might not want to export. Let's just create a class. Kill sleep exception. And I mean, I don't even really think I need to give it any data right now. Perhaps in the future, I would like to give it, some of this stuff. Maybe. But for right now, no. I'm just going to make an empty class. And then what I'm going to do is reject new kill sleep exception. So we're going to reject with this object. That will be thrown. Then what happens? That's a good question. Many people are asking this question. Let's go into here, try this, catch, some exception E, well, if not E, instance of, okay, so perhaps I do need to export this after all. Export. Kill sleep exception. Okay. Not instance of kill sleep exception. And Alt Shift Enter to add that. So if it's not this, rethrow the exception. Otherwise, don't worry about it. Just leave. So here we go. So if the kill switch exits early, it'll hit this catch, it'll skip all this other stuff, it'll exit here, it'll clear out our event, and everyone's happy. All right, the moment of truth. Is this gonna crap the bed? So far, not crapping the bed, and it's working. And this should not leak memory. We can, we can test this. Console.log sleep train was killed in its sleep, died peacefully. Beautiful. You love to see that kind of message. Sometimes I forget to remove my debug messages from the code, and it makes people think. It really makes people think. And I like them thinking. I like them thinking that guy, he could snap at any moment. We'd not fuck with him. All right. There you go. See, look at it. Sleep train was killed in its sleep, died peacefully. Although I don't know why we're only getting one. I feel like we should be getting multiples. There you go. Yeah. That's what you want to see. Beautiful. Okay. Chili has once again saved the day. Now, I mean, there are things... I don't like having to put this in here. What I could do is I could make a little utility. And, well, let me just show you what I'm thinking. I don't know if I want to use that utility, but I'll show you what it looks like. So, export function. I don't know what I'm going to call it, so let's just call it sleep train. Because, you know, that's the train that we're on right now. That's where we're at in our life, basically. Now, the sleep train is an async function, which I believe you put in JavaScript. You put it there. Yes. And it is going to take a function f, an f function. What is it going to do? Well, it's going to do this stuff. Now, here's the trick. Can TypeScript await a function if it doesn't have information about, you know, whether it's an async function or not? Await f. It seems to work. So we put the nastiness in here. Then in here we do, let's try it out. Sleep train, Alt Shift Enter. We give it a boy, like this. The thing has to be async. And we await this boy. So this is cleaner than this, certainly. But it will stifle that exception, that cancel exception, very nicely. Now, before I delete this code, well, I mean, I could just undo. That's fine. I'm going to delete this. I'm going to run it. We're going to see if it still works, first of all. Then if it does work, there's one more thing I want to do. I might want to have some way of limiting this, telling TypeScript that this function has to be an asynchronous function. But we'll cross that bridge when we come to it. So the compiler likes it. The compiler is like, this is cool stuff, Chili. You're really breaking new ground. But yeah, okay. Scared me a little bit for a second, I'm not gonna lie. Well, it's still working. It is, don't type in Japanese though. We don't wanna, yeah, it still works. It's beautiful. And it's much cleaner than before. So we can await sleep train, and then we can sleep, and we can do tasks, and we can sleep again, and we can have a whole train of tasks that are, you know, timed out with delays in between them. And a kill switch can cancel them at any time, and everyone's happy. No one's leaking, no one's pissing the bed with memory, and Chili is happy. And when Chili is happy, you know that good things are in the offing. Now, can I tell TypeScript that this function needs be an asynchronous function? All right, so apparently, and this makes sense to me, basically, if I want to make a more limited type of function type that is sort of asyncy, I should specify that I want a function that returns a promise, because that's basically what it is. But I don't want to limit it to a promise of a certain value. I just want to say a function that returns any kind of promise, that's my boy. So if we go down here, we have perhaps a generic type. Promise here, this one here, generic type, async function, arguments, return type, promise O. So if I do this, can I smash Becky? Okay, well, I don't know why this is hangry, but it's not that important. I mean, I don't need to make, for this simple use case here, we'll call this one a sleep train. And yeah, sleep train is just a function that takes nothing, and it returns a promise, but the promise doesn't contain anything. And this thing takes a sleep train. And yeah. Okay, that's fine. That should be fine, right? And you're happy. But what if I were not to make this async? Well, the IDE isn't smart about it, but let me see if the, well, first of all, I can't await if it's not async. Am I wasting everyone's time here by going down this rabbit hole? Yes. Yes, I am. But that's not it's never stopped me before, has it? All right. What do you like? Yeah. Something void is not assignable to parameter type sleep train. Yeah. So if I tried to do something like this, it would tell me, no, you're dumb. Go to hell. If I were to do this, I mean, it would work, but it would, it's kind of dumb. If I were to try to do this, it's not going to let me do this, right? Of course not. You can't await if the function is not async. If I do this, then everyone's happy. So here we go. We've mastered everything. We are the masters of the universe. We're the prince of the universe, and I'm happy. And as we've established previously, when I'm happy, good things are afoot. But video, looking at the time now, and sometimes I take breaks when I'm recording, so I don't know how much of this is actually going to end up in the final video, but the clock is telling me it's an hour and 20 minutes, and that's a lot of video. But these videos, they're not just like a quick package, like the C++ tutorials usually are slightly quick. These videos are just about me messing around, making things, and also exploring ideas and just talking them out, talking to you guys. So, that's what you get. And if you don't like it, some people like it. So it's not always about you. I'm going to commit this code, fixing async leak. And that's where we're gonna leave it off. Now, in the next video, I plan on implementing the deletion of things. We're gonna delete that. We're gonna talk about how we want it to work in the UI, and we're gonna implement the functionality in the back end and get something down. But that might not be, especially for the way the user interface is, probably won't be my final thing. Because finally, I would like deletion to happen via swipe. By a neat little swipe interface, very mobile type interface, because it's going to be used from a smartphone. But probably won't start off there because UI stuff, I hate it and it takes time, and I just want to get something that works right now. But anyways, yeah, see ya later with some more Pantrio.